All right. Yep. Thanks, Grant. For those who haven't met me before, my name is Diamond. I'm a staff engineer here at Replicated. I work on the customer reliability engineering team, which is the team that maintains the troubleshoot project and also works closely with vendors during the early stages of onboarding through advised engagements. And today I'd like to take some time to talk about best practices for packaging Helm charts as an ISV. At Replicated, we recommend using Helm because it's the best way we think to distribute Kubernetes applications in the enterprise. And we frequently collaborate with ISVs to help them create enterprise-ready Helm charts. And in this talk, I'll cover key patterns and practices that we've learned over the years, along with some common challenges and considerations to watch out for. So building flexible Helm charts, one of the biggest things that we've learned when it comes to packaging Helm charts is to make sure that they are flexible in their configuration. Consumers of your chart may need to modify different aspects of how your application is deployed based off of the tools and supporting infrastructure that they have running inside of their clusters. And so there are some essential properties that we recommend that you start with, the first of which is labels and annotations. Because many tools in the Kubernetes ecosystem rely on labels and annotations to provide additional configuration, we feel like this is a no-brainer. And some examples of that are projects like Valero or Cert Manager, Prometheus, which all rely on labels and annotations that your users will potentially need to add. Image properties. So allowing the image properties to be configured is like pretty essential as well. Users may need to have, they may have a need to push your images into their own registry, in which case they need to change the registry for all of the images inside of the Helm chart. Modifying the image tag can be useful for debugging and development, and users who will also need to modify the registry will probably also need to modify the image pool secrets to authenticate against that different registry. And also wanted to make a note here of, a really good example of when you might need to override something like the image properties would be when you're integrating with the replicated platform. So when you're supporting embedded cluster installs and you're using our registry proxy to access images in an external registry, you'll need to override the registry and the repository in your kind Helm chart resource with the necessary templates to dynamically determine the image name. So you can see an example of that here in the snippet using the replicated functions. Security context. For clusters with strict security requirements, users may need to modify the security context to meet the cluster-specific policies and constraints. This is commonly seen in environments like OpenShift, where security policies are more strict by default compared to other Kubernetes distributions. For example, OpenShift enforces default security context constraints that may prevent containers from running with elevated privileges, using certain capabilities, or accessing the host file system. And as a result, users deploying into these clusters will often need to modify the security context in order to accommodate this. Yeah, so node selector, affinity, and tolerations also important for controlling how your application is scheduled into a Kubernetes cluster. So it's a good idea to make these configurable as well. For example, there may be specific nodes with hardware that your application requires, and users may need a way to opt your application into running on those specific nodes. Or maybe users would leverage affinity rules to determine how a stateful application like Postgres is distributed across the cluster. We've seen this as users may want to ensure that replicas of a stateful application, like databases like Postgres, are spread out across multiple failure domains like availability zones to guarantee some fault tolerance. Kubernetes services, really important here as well, especially the ones that are exposing your application, making this configurable, definitely a best practice. We've already discussed the general kind of usefulness of labels and annotations. That again applies here, but it's also important to consider making the service type configurable. Some users may prefer a load balancer service type, while others may opt for a node port if the automation to create a load balancer is unavailable. And so we think it's helpful to, expose that service type configuration. And it's also helpful to allow the node port value itself to be configurable in case someone doesn't want to use the default value that's assigned dynamically whenever you create a node port service. Ingress. Yeah, this is another no-brainer here. Consumers of the chart may need to set a specific ingress class to match their cluster's configuration. And as with other Kubernetes resources, labels, annotations, again, really important here. And annotations in particular is really the primary method for how you configure ingress. And additionally, users may need to control the TLS configuration to manage secure access to the application. And in this snippet here, you can see in that TLS section that you might also consider um, adding a really quick way for someone to turn TLS on and then just get a self-signed cert that you generate inside of the chart. So lastly here, a common pattern is allowing users to reference existing Kubernetes objects like secrets or service accounts. This approach is particularly useful for organizations with pre-existing infrastructure or strict security policies. For example, users may want to provide an existing secret for credentials if they are externally managing a dependency of the application, for example, a database or a message broker, and specifying an existing service account that has predefined permissions and roles could be required if they have more stringent RBAC. So this sort of brings us to, how much flexibility does there need to be inside of your Helm chart? At the end of the day, you can never fully anticipate what a user may want to configure, but we recommend that you template what you think about 80% of chart consumers will use. And then for the remaining 20%, you may get those one-off requests to template things that you didn't previously think about, like additional volume mounts and containers. And when that happens, you'll just have to balance the growing complexity that can bring to your Helm chart with whatever your um, requirements are of your users. So packaging with the replicated SDK, a quick mention of this, because we of course believe that including the SDK in your Helm chart is a best practice as well for Helm, especially for ISVs. And so, an overview here of, what the SDK is, if you're not already familiar, is that it provides access to key replicated functionality available in our distribution platform. You can very quickly get access to insights and operational telemetry for instances running in customer environments. The SDK also provides an in-cluster API that you can use to enable replicated features from your application, like collecting custom metrics, checking license entitlements, update checks, and automatically tagging that particular instance to correctly report, for example, what environment it is, maybe prod or staging or something like that. And so packaging the replicated SDK is as simple as adding it as a dependency to your chart.yaml. When packaging subcharts, there are many different repository types that you can use. In this example, you'll see that we're using an OCI registry, but there's also, file-based HTTPS, Git, and you can use standard Symver version range syntax when you're referencing the versions for these different dependencies. So in this snippet, you can see how I'm using the caret at the beginning to automatically get new minor version updates. So keeping your Helm charts dry, which stands for don't repeat yourself. The more resources you add to a chart, the more repetition there can be. So, what are some ways to keep your Helm charts dry? One of the big ones here is helper functions. Helper functions in Helm are useful for keeping your chart organized and easy to work with. They let you create reusable templates and logic, which helps maintain consistent naming conventions and cuts down repetition in your manifest. As opposed to specifying the same labels multiple times across your entire chart, you can reuse the same set of labels that are defined in a helper function and then just reference that function instead. This same pattern is helpful in any instance where you're finding a lot of repetition in your chart. And these functions can also enforce best practices like checking input values or enforce name length limits, which can help you create charts that'll be easier to maintain. And these are commonly placed inside of a helper's template file inside of the templates directory. But technically that template file, it could be named anything. And I also wanted to give a quick mention to library charts. A library chart is essentially a chart that contains a bunch of helper functions, and you can reference these charts as a dependency inside of your chart.yaml to import all of those functions. So Bitnami's common chart, which many of you may have already seen or actively use it, is a really good example of this. This can help keep chart development sustainable as you add additional resources to it. So what are some more notable patterns that we've seen when um, developing Helm charts? A big one is pod restarts on config map or secret changes. So it's important to know that pods that source environment variables from config maps and secrets aren't automatically updated whenever those resources change. Kubernetes doesn't provide a native way to enforce this rollout, so we recommend adding some additional templating to your Helm chart as a workaround. So by including an annotation in the pod template, as you can see in this below snippet here, that represents a checksum of the reference config map or secret, you can ensure that whenever those resources change, the pods are automatically restarted as well. Embedded versus external components. So, for certain dependencies of your application, like databases and object storage, flexibility in how they can be deployed, we see, as being a very common best practice. We recommend that you always provide an embedded option within your Helm chart for like a more streamlined setup, while also allowing the option for users to deploy their own and disable your embedded option. For example, users can choose to use your embedded Postgres for convenience, while others might prefer to deploy their own instance of Postgres separately, depending on their requirements and preferences for how they run their infrastructure. Persistent secret values with the lookup function. So this is a pretty common use case as well. If you ever need to retrieve an existing secret value to prevent overriding them after an initial install. This is ideal for randomly generating secret values like passwords or encryption keys that should remain unchanged after that initial install. There are some caveats here, as the lookup function is sometimes not supported in certain tools that deploy Helm charts, but it is technically a Helm native solution to this problem that certain users may be able to take advantage of. And we also recommend, where possible, that you distribute, a single chart instead of multiple of them. Benefits here being, that ease of installation and upgrade. Users can install a chart with a single command, really simplifies the process. And same thing when it comes time to deploy your Helm chart in CI or GitOps pipelines. It'll also make things simpler there as well. And you also get that um, separation of concerns potentially with multiple teams maybe managing different Helm charts, and those get sort of rolled up and referenced as dependencies, and it can make it more sustainable if you choose to do things that way. And so that approach can allow for some clear ownership and management of dependencies, ensuring that changes in one chart can be easily reflected in the overall deployment without disrupting other teams. And yeah, the last thing, a single artifact is also, of course, going to be easier to test with. All right, some considerations, values files. Definitely the more resources you start putting into a single chart can become overwhelming. Um, Not really any workaround around that. And then also resource ordering within a single chart can be a challenge inside of, you know, a single chart, depending on if you're distributing operators and you need to maybe install some CRDs before you install some custom resources. Situations like that maybe can become more difficult when you're distributing a single chart. So just some things to be mindful of. All right, so common challenges and considerations. So distributing infrastructure dependencies, when it comes to distributing projects like Istio, Rook, Vault, and others, we advise that, folks be mindful of the fact that you may not get access to install these projects in the cluster, and it's generally better to let the cluster operator manage these sorts of dependencies. We make this recommendation mainly because it can bring a lot of complexity to your packaging and could result in a much higher support burden. And at the very least, similar to what I mentioned previously for some of those embedded versus external dependencies, you'll want to make sure that users can optionally disable any infrastructure dependencies like this that are packaged in your chart in favor of their preferred way of satisfying requirements like storage, networking, or secrets management. Evaluating dependencies for enterprise readiness. So this is very important. You have to ask yourself some questions. Is the upstream chart that you're using, is it being updated consistently? Is it trusted and widely adopted by the community? How do they handle upgrades? For example, we found with the commonly used Bitnami Postgres chart that they require users to manually intervene and upgrade the database. Perhaps for a POV or during the development process, that could be suitable, but it would likely cause some friction in production use cases. And for this reason, we are sort of advising people to weigh the pros and cons of using operators for some of these more complex dependencies like databases. And so we mentioned cloud native PG for Postgres, for example, as it takes more responsibility for day two operations. But it doesn't come without its challenges because, as I mentioned before, once you start distributing components in your chart that require, you know, some of that cluster level sort of access, it can be challenging when installing into some shared Kubernetes clusters. So you'll need to kind of be mindful of all of that. Distributing operators. So there are some things to keep in mind here. We've seen some enterprises enforce the requirement that an application must be installed into a single namespace in shared clusters. So you'll have to, be mindful of the requirements of that cluster that you're installing into, and maybe even be prepared to talk about getting some exceptions for your application depending on how it's architected. If you're distributing an operator, only having access to a single namespace, obviously that's going to be challenging because you need that cluster level access to install your custom resource definitions. And yeah, also resource ordering becomes more of a factor as you start installing operators. You'll likely want to make sure that your CRDs and the operator are installed before any custom resources are created. And if you run into some race conditions where that becomes an issue, that could be problematic. And that's probably one of the biggest reasons we see people having to end up with multiple charts instead of a single one. So many of the things that I mentioned today, not all, but the vast majority, is available to be seen in our platform examples repository, where we have a bunch of different useful patterns. We're constantly kind of iterating on this and trying to improve these. And there's not just Helm best practices in there, but there's also some, best practices for using the entire replicated platform and distributing a Helm chart into embedded cluster. So we definitely encourage everyone to take a look. Hopefully you find it useful and definitely give us feedback.